Welcome to the part third of our programming video. So in this video, we are going to basically focus on the matrix operations in R. So why do we use matrix? Basically to store numerical values in different rows and columns. Then to perform matrix operations, which are very essential in data science. Now, for example, uh, we can use a function called matrix in R to create a matrix. So it has different, as you can see, there are different arguments in this. And so first one is basically data. So we have provided data using the C function and some random data. The second argument is n row, which is number of row. And third, this argument n call is for the number of column. Although once we provide number of rows, we don't need to provide number of columns because it automatically calculates the number of data and accordingly it creates the matrix. Now by row, by default it is false. Suppose you want to create a matrix using by row, that means you want to place all these elements row wise, then it has to become true. So we supply true here instead of false. By default it's false. And then dim names, basically the names of dimensions, so names of rows and columns. So it always accepts in the list form. There are different data types, we will discuss that later. One of the data types is list. So the first one is for the row and second one is for the column. So you can see this, it has created a matrix which has 2 rows and 3 columns, and the names are also given here. So you can see we chose by row as false. So you see the data has been selected column wise here. That means the first 2 data points you see, the first column, second 2 data points in the second column. Likewise, all the columns have been filled by this matrix. No, so the function is called matrix and it has various arguments as we discussed already: data, the number of rows and columns, by rows and dim names. So how to create we saw in the example already how to create a matrix by using the function matrix. There are other ways as well to create a matrix. So what we can do is we can combine 2 vectors or multiple vectors to create a matrix. So we have defined one matrix, one vector here, A. It has 3 elements or 3 points, data points, and then in the previous video we forgot to mention this point that you can assign name to a vector, so name to each element. So this is the way you use this function names, and in the bracket you place the name of the variable, and then using the C function you can assign name to each element here. So now this is the second example of vector. So we have created 2 vectors here, and we'll see how to create matrix using these 2 vectors. So if you want to create row wise, there's a function called rbind. So you use rbind function, the bracket you put the names of those 2 vectors. Depending on the order, it will create suppose if here we have placed A first and then B next, if we can reverse the order, and accordingly the matrix will be created. So you can see here the matrix has been created. The first row is A and second row is B, and it has used the name of the first vector because it has used this as basically what it has done is in the first row it has first elements, in the second row it has second element. Since we are creating this matrix using rbind function, so the names of the row will be the names of the vectors. So here the name of the first vector is A and B, so it will automatically select the name of the column as the first vector, whatever is the first one. So that is how it is going to work. Then the column wise if we create, then again it is we can see that it automatically selects so for the column wise we are using the function cbind, and we are using the same those same two vectors A and B. So now the A becomes first column and B becomes second column, as opposed to the previous example where A became first row and B became second row. So here again we see that it has picked up the name of the first vector because we placed first here. Had we used the B as the first column, then it would have picked up the names of the B vector, so it would have been b1, b2, b3. Here, same likewise here also, if we had reversed this order, then this would have been b, this would have been a, and then the names also would have been from the b vector. Now suppose you want to display the the first element of this vector. Okay, this also we forgot how to index because we did not cover the names function in the vector video. So in case you want to display the elements of any vector by name, by their respective name, so you can just use the square bracket and use that particular name of that particular element corresponding to that element, and it will display that particular value. So matrix of course takes the names of the vectors as discussed. So indexing in matrix is very simple in R. So basically what we do is there is a function called dim, so which displays the total number of dimensions and the values in R. So if you put dim inside the bracket, we put the name of that matrix, it will display the dimension of the matrix. First one is for row, and second one is for the column. So 2 rows, 5 columns is 2 by 5 matrix. Now we want to, let's say you want to display the value in the first row and second column. So first row and second column. First one is for the row, second one is for the column. So you get the value, it's like 3 here. Now suppose you want to display the values of all the rows in the second column. So you don't put anything here before comma. After comma you put the number of the column, and it will display. So see, row 1, row 2. There are only 2 rows in this matrix, so it is displaying both the rows. Same goes with the column also. You want to, let's say you want to display all the columns, then you just mention the row number and after comma don't write anything, and it will display all the columns. Suppose you want to display the particular columns in a row, so you mention the row number here, and you can separate the first column and the last column that you want to display by colon, and it will display the result. See, third column, fourth column, fifth column, 5, 7 and 29 here. Similarly, you can also display the values using the names of the rows and columns. So you can just mention the name of the row here, and after comma the names of the column. If you want multiple rows, then you use the C function this side as well. So this will give you the result here. So we can do this way. Now let's look at the matrix operation. So there is a function called apply in R, which can be used for vectorized calculation. So suppose you want to calculate the mean of each row of the matrix. So you use this function apply. First one argument is the matrix itself, second is whether it is row wise or column wise, and third one is for the function that you want to apply. So you see it gives you the row wise calculation. Similarly, if you want to calculate column wise, then instead of 1 you put 2 here, and it will do the calculation. So it will give you the mean of each column. Now suppose you want to know all the index or indices of all of the matrix which have the values more than 6. So what you do is you use this method. So you use you write the name of the matrix greater than 6, assign it to y. So y is another matrix which will give you the index, or create another matrix which has false and trues. So wherever you have false, that means all the values in these places are less than 6, and all the or less than or equal to 6, and all the places where you have trues, that means the values are greater than 6. Now there is another technique in R. What you can do is you can multiply that matrix with this y, and it will give you a result something like this. So what it does is all the false is 0 and all the trues are ones. So it automatically multiplies, it does the element wise multiplication. So whenever you're using asterisk, it means or star, it means it's element wise multiplication in matrix. So R automatically converts all these this matrix into zeros and ones. For all the false become zeros and all the trues become 1, and then it does the element wise multiplication, and therefore wherever you have false it will become 0, and wherever you have true it will become 1, and 1 into the actual value so of that particular element. So you get the matrix which has all the values greater than 6. That's the argument we have taken here. So this is a very nice way to do it in R. So let's look at more operations in matrix. So we have created two matrices here, M1, M2, same elements, but first one is 2 by 3 and second one is 3 by 2 matrix. So if you want to do normal matrix multiplications between two matrices, we use this symbol percentage star percentage M1 in M2. So two matrices, and then you get the result. And as we know in matrix that when we do normal matrix multiplication with two matrices, the resultant or the output matrix will take the number of rows from the first matrix and number of columns from the second matrix. So it becomes 2 by 2 matrix here. If you want to do element wise multiplication, you can do, but for element wise multiplication both the matrices should have the same dimension. So that's why we are using M1 both the sides, so you get this result. And then you can do the same element wise subtraction and addition using the same method. Just replace this sign symbol, like from star you use minus sign and plus sign. Now we look at the matrix with a scalar value. So suppose you want to multiply each element of a matrix by a scalar value, you can use this method M1 into 2 star 2, and it will multiply each element of M1 by 2. Now you can do the same way for addition and multiplication. So we have done that. We have subtracted 2 from each element of M1 by using this method. So let's look at some more matrix operations here. So one of the important operation is between matrix and vector. So we have created one vector here v1 which has these 3 elements, and then we are using the example from the previous slide, that m1, and we want to do normal multiplication. So what R does is it treats this v1 as a matrix here, and it converts this vector into 1 by 3 matrix automatically, and that's what you get, so 2 rows, so the resultant output matrix will be 2 by 1 matrix. Now suppose you want to do element wise operation between a matrix and a vector. So that's possible using a function called sweep in R. Sweep can be used for other data type also, but here we are using matrix. We are focusing on matrix, so we will focus on matrix. How it works is, so you need to supply certain arguments here. The first one is the matrix, second one is the margin. So 2 means row wise, 1 means column wise. Third argument is the vector itself, and the last argument is function. So whether you want to do multiplication, subtraction, or addition. So that's what we do here. So you see when we apply this, what we get here. So what it does is, so this becomes a row here because we have selected 2 here. So this becomes row, and it element wise it multiplies. So first value is 1, and in the matrix M1 the first element here is 2. So 2 into 1 is 2. The second element in the M1 is 5, and therefore 2 into 5 is 10, and this was 9, so 9 into 3 is 27, and again you go to the next row and you get the same result. Now you can do the other element wise function as well. You can use addition here. But again, if you're using the same vector, then margin has to be 2, because the number of columns or number of elements in the first row or second row in each row has to be same as the number of elements in the vector for if you're using margin as 2, which is row wise. If you are doing it column wise, then we have to use a different vector, because the vector has to have two elements, as each column has two elements only, and therefore we are using a different vector here. So see, this is what it has done. It has added 2 to each element in each column. Sorry, not 2, but 4 and 5. So first one was, as we said, the value was 2, so 2 plus 4 becomes 6, and then this must have been 4 here, so 4 plus 5 becomes 9, and this must have been 5, so 5 plus 4 is 9. So similarly, all the values have been, added to each other. So thank you so much for spending your precious time on this presentation, and I hope this has been very helpful. So in case you like this video, please like, share and subscribe. Thank you.